You ever feel like you're just swimming in information, but, still missing the crucial connections? Or maybe wondered how these incredibly complex systems, like tiny particles or even whole galaxies, seem to just pop into existence?
Yeah, it's a common feeling. And what if the very act of observing something wasn't just passive looking, but actually uh, actively sculpting the reality we see?
Exactly. So today we're diving into this really fascinating framework from our source material, Universal Observer Group Set, or UOGS, Foundations of Hyperspace Physics.
Mm-hmm. And our goal really is to try and unpack how interaction, in the biggest sense possible, influences this thing called coherence.
Right, and how that process gives rise to, well, pretty much everything we
It's
experience.
a big idea.
It is. And here's the core question we want you to keep in mind throughout this deep dive. What if everything that interacts with the system seriously, from a scientist in a lab coat to a massive black hole, what if it's all acting as an observer?
An observer that actively shapes reality.
Yeah, actively shaping the reality we perceive. So think of this as your shortcut to understanding this honestly revolutionary idea. It suggests ordered states are like the blueprint, and from them, unimaginable complexity is born.
You should definitely expect some haha moments today. This perspective could really change how you view the universe.
Okay, so to get started, there are two key ideas from the source we need to grasp. First up, coherence.
Right. Coherence. You can think of it simply as the measure of correlation or alignment. How synchronized are the parts of a system?
Like instruments in an orchestra playing perfectly together.
Exactly. High coherence means things are moving or vibrating together, kind of in perfect harmony.
Okay, and the second concept.
That's emergence. This is that amazing, often really surprising thing where totally new properties or behaviors just sort of arise from interactions within a system. It seems like they come out of nowhere.
Almost magical. But the source says it often happens through something called symmetry breaking.
hmm Picture a perfectly symmetrical object, like a sphere. If you change it just a tiny bit, break that perfect symmetry.
New features appear that weren't obvious before. Got it.
So that brings us to the framework itself,
Yeah.
the Universal Observer Group Set, the UOGS.
And it's more than just a theory, isn't it? It's like a new lens for looking at interaction.
That's a good way to put it. The source defines the UOGS as a framework that includes all entities or processes, literally anything, that can reduce coherence or symmetry in a system.
So it's a completely new way to classify how things observe or interact, and that interaction leads to new properties showing up.
Yeah, and what's really compelling is how this could, well, fundamentally change how we understand observation in physics, and maybe even beyond.
It directly links observing or interacting with reducing symmetry, coherence dynamics, and resonance.
Exactly. Interaction isn't just passive measurement anymore. It's an active, transformative force.
Okay, try thinking of it like this. Imagine a universal filter. When this filter, which the UOGS calls an observer, acts on a system, it reduces that system's coherence, its symmetry. And when that happens, boom, new properties or patterns emerge. They literally appear, things that weren't there before.
It's like stirring a perfectly still pond. You break the surface symmetry and suddenly you see ripples.
Right, the ripples weren't hiding in the still water. The interaction created them.
Precisely.
Yeah.
And this leads to another fascinating aspect. The UOGS organizes these observers into a hierarchy.
A hierarchy. So not all observers are created equal.
Not at all. They operate at different scales, different levels of interaction. It's a whole spectrum of influence.
Okay, break that down for us. What's at the bottom, like the most concrete level?
At the most concrete level, we have localized observers. These are the ones we usually think of when we hear observation in science.
Like someone actually running an experiment.
Exactly. Human experimenters in labs, instruments like cameras, particle detectors. The source even mentions quantum computers.
How do quantum computers fit in?
Well, in quantum computing, you intentionally reduce coherence through computational cycles to get a specific result. That's a localized observation process.
Okay, makes sense. So tangible interactions shaping quantum states. What's the next level up?
Stepping up, we find intermediate observers. These are more like natural phenomena. They bridge the gap between the really big stuff and the localized interactions.
Natural phenomena acting as observers. Like what?
It's pretty cool, actually. It means it's not just us or our instruments watching. Nature itself is constantly observing.
How so?
The source gives examples like entropic processes, thermodynamics, things tending towards disorder. That increase in disorder reduces coherence.
Okay.
And also environmental interactions. Think gravitational fields, electromagnetic fields. They're constantly affecting systems, subtly influencing their coherence, so they act as observers too.
Wow. Okay, so nature's forces are part of this observation hierarchy. What's at the top? This sounds like it's building to something big.
It is. This is where it gets really mind-bending. At the top are higher dimensional observers. The source calls them asymmetry resonance operators, or AROs.
Asymmetry resonance operators,
Yep.
AROs. Okay, that sounds abstract.
They are the most abstract and the most powerful, supposedly. They operate at a level the source calls hypersymmetry.
Hypersymmetry.
Yeah, think of it as a deeper, more fundamental level of symmetry. These AROs mediate large-scale transitions in coherence. They're described as fundamental operators that transform symmetry into asymmetry.
And this links hyperdimensional coherence to the properties we actually see.
That's the idea. The source mentions cosmological examples like hypergravity and coherent resonance, massive universe-scale forces acting as these AROs.
So this really opens up a wild possibility, doesn't it? What if there are observers operating at scales way beyond our direct understanding?
Exactly. Observers subtly influencing the fundamental laws, the structure of everything. The source even suggests AROs can generate gauge symmetry, basically, create the fundamental forces we know by reducing this hypersymmetry.
Okay, my head is spinning a little, but in a good way. So we have this hierarchy, localized, intermediate, and these higher dimensional AROs. It's not just who is observing, but how they all fit together, right?
Absolutely. They don't act in isolation. The UOGS paints a picture of a dynamic, interconnected network.
A network. How does the influence flow? Is it just top-down?
Mostly, but there's feedback too. So, yeah, the higher dimensional AROs can influence or modulate the effects of those intermediate entropic processes, like setting the rules for how disorder spreads.
Okay.
And those intermediate processes, like entropy or gravity, can then influence the outcomes of localized quantum measurement.
Right, environment affecting experiment.
Yeah.
Makes sense. But you said feedback, bottom up.
Yes. And this is the kicker. Observational feedback from localized actions, like us doing an experiment in a lab, can actually feed back up the chain.
Wait, really? Our local actions can influence larger scale dynamics.
That's what the source suggests. It implies our observations might send ripples back up, informing those cosmic scale coherence dynamics. It suggests a universe that's incredibly interconnected and maybe even responsive.
Wow, that is profound. And you mentioned the source uses math for this, block matrix systems.
It hints at a very precise, quantifiable interplay, like a complex, perfectly mapped system where every interaction up and down the hierarchy is accounted for mathematically.
So all these interactions, this whole hierarchy, it all comes back to this core concept of coherence.
Exactly. The source identifies coherence as the unifying principle. It governs how complexity emerges at every single scale.
Okay, so let's walk through that transformation again. High coherence means?
High coherence generally means strong symmetry. The components are highly correlated, locked in step. Think quantum superposition or entanglement states of perfect synchrony.
But then an observer interacts.
Coherence gets reduced.
And that's the crucial moment. As coherence goes down, symmetry breaks. And that symmetry breaking is what allows totally new properties to emerge. Like a tightly wound spring suddenly uncoiling into a new shape.
That's a decent analogy. A new dynamic form appears that wasn't obvious in the tightly wound state.
And we see examples of this everywhere, right?
All over the place, according to the source. In quantum systems, we already mentioned it, high coherence is key for things like superposition. Lose that coherence, quantum decoherence, and the system collapses.
Right, it picks a definite state. That's the basis of classical reality emerging from quantum fuzziness. And it's a huge deal for quantum computing.
A huge deal. Loss of coherence is the enemy of quantum computation. It destroys the delicate quantum states needed.
Okay, what about entropic processes? How does coherence play out there?
Think about low entropy states, like a perfect crystal lattice. That's a state of high coherence, high order.
Atoms perfectly aligned.
Exactly. But as entropy increases, as things get more disordered, coherence diminishes, and that leads to macroscopic properties like, say, thermal equilibrium. Everything just becomes a uniform mush, coherence loss.
And source mentions biology, too.
Yeah, it suggests that coherence in molecular vibrations allows for really efficient energy transfer in biological systems. But when that coherence is reduced, the energy just dissipates as heat. It's like the difference between a tuned engine and one just getting hot.
Interesting. And phase transitions, like water freezing.
Classic examples. Think about the collective behavior in a superfluid, all the atoms moving as one coherent unit. or the coherent electron pairs, Cooper pairs, in a superconductor allowing current with zero resistance.
High coherent states.
Right. But if you increase the temperature, for example, that coherence diminishes.
And a new phase emerges, like normal fluid behavior or electrical resistance reappearing. The ordered state breaks down.
Precisely. It's a direct transition driven by the change in coherence.
And this isn't just physics. It extends to larger complex systems.
Absolutely. The source points to biological systems where coherence in neural networks or molecular interactions might underpin emergent things like consciousness, perception, or efficient metabolism.
That's a huge claim, coherence enabling consciousness.
It's definitely out there, but it follows the logic. And in social systems, think about coherence in collective behavior, leading to emergent things like cultural norms, economic trends, or even mass migrations.
Groups acting in a synchronized, coherent way, creating something larger than the sum of its parts.
Exactly. And even cosmologically.
Yeah.
The idea is that coherence in quantum fields way back in the early universe influenced how matter clumped together, how galaxies formed, the whole large-scale structure we see today.
Wow, so from quantum fuzz to galaxies, it's all linked by this dance of coherence and emergence.
And mathematically, this isn't just hand-waving. High coherence corresponds to stable, ordered mathematical descriptions. Low coherence leads to math that reflects more dynamic, less predictable, emergent, or even chaotic behavior.
It maps the transition from order to complexity.
Precisely.
Okay, this sounds incredibly deep, almost philosophical. But you mentioned math. The source material isn't just speculating, is it? There's a mathematical structure behind this UOGS framework.
Oh, absolutely. It's grounded in some pretty sophisticated mathematics. The source uses what's called the Lie group framework.
Lie groups, I've heard of those. They relate to symmetry, right?
Exactly. It's the mathematical language for describing symmetries and, crucially, how symmetries change or break in complex systems. It allows for a precise, quantitative description of these observer dynamics.
So it's not just concepts, it's equations.
Right. They can break down the dynamics, mathematically specific components for the AROs, the intermediate natural observers, the localized ones. It gets very specific.
And the source mentions commutation relations. What are those, in simple terms?
Think of them like fundamental rules of interaction. Algebraic recipes that tell you exactly what happens when different types of observers encounter each other.
Okay, give me an example.
Well, the source suggests mathematically that when two AROs, those big, higher dimensional observers, interact, the result isn't random. The math shows how their interaction can actually generate a fundamental force component, what physicists call a gauge symmetry element.
So the interaction creates part of the laws of physics.
That's the implication. Or take entropy, the tendency towards disorder. When it interacts mathematically with a quantum field's coherence, the commutation relation describes precisely how that leads to decoherence, the quantum fuzziness disappearing into a clear classical state.
And for a lab experiment.
Same idea. The math for a localized observer, like an experimental apparatus, interacting with a quantum system shows how it forces the system into a definite state, what we call wave function collapse.
So these mathematical rules predict the outcomes of observation at different scales.
Exactly. And they can even represent these transformations visually, sort of, using matrices, specific mathematical arrays like blueprints.
Blueprints for reality emerging.
In a way, yes. Matrices for how AROs break hypersymmetry, matrices for how entropy reduces coherence, matrices for how a measurement causes collapse, different matrices with specific coefficients representing the strength and type of interaction.
Sounds incredibly detailed.
It is, and this mathematical sophistication is what takes it beyond just an interesting idea. It offers a potentially unified, quantifiable way to understand how observation at all these scales leads to the reality we know. It aims for prediction, not just philosophy.
Okay, so bringing it back to us, to you listening, why should we care about all this? It sounds fascinating, but what are the implications, the applications?
Well, they're potentially huge and quite exciting.
Let's start with tech. Quantum computing came up earlier.
Definitely. Understanding coherence and, crucially, how it gets reduced or lost is absolutely fundamental for building stable, reliable quantum computers. If you can precisely model and predict decoherence using this UOGS framework.
You could design systems to protect against it or work with it more effectively.
Exactly. More robust quantum tech.
What about biology and health? You mentioned coherence there too.
Right. If we can deeply understand coherent processes in our bodies, molecular vibrations, neural signals, maybe this framework offers new ways to think about health and disease.
Like restoring biological coherence to treat illness.
Potentially. It could lead to totally novel approaches in medicine, targeting the underlying order and harmony within biological systems. It's speculative, but the potential is there.
And zooming out again, cosmology.
The UOGS, especially the ARO concept, could give cosmologists powerful new tools. Tools to model how the universe's large-scale structures, galaxies, galaxy clusters, actually emerged from the early universe.
By understanding the observational role of fundamental forces, and maybe even these hypothetical higher dimensional ones.
Precisely. It might help unlock secrets about the universe's very beginning.
And the source hints at even more. Consciousness, universal structures.
Yeah, gestures towards some very profound areas, suggesting this framework might offer a new lens on, well, almost everything. It's really just scratching the surface, feels like.
Okay, let's try to wrap this up. We've covered a lot of ground today. We started with coherence and emergence.
The basic building blocks.
And then we explored this incredible hierarchy of observers in the UOGS framework from localized lab experiments.
Through intermediate natural forces like entropy.
All the way up to these abstract, powerful, higher dimensional observers, the AROs.
And we saw how they're all interconnected, interacting dynamically.
Right. It's not just abstract theory. These interactions have tangible consequences across quantum physics, biology, cosmology, maybe even social systems. And it's all unified by this idea of coherence being reduced, symmetry being broken.
That really is the core message, isn't it? Coherence is the key ingredient. It sets the stage for complexity to emerge from order. High coherence means symmetry, stability, reduce that coherence.
And new asymmetric complex structures can arise.
Yeah.
And it's the constant interplay of all these observers at every level that drives this whole process reality constantly unfolding.
Well put.
So here's something to leave you with, the final thought to chew on. If every interaction, literally from the tiniest quantum flicker to the gravity between galaxies, acts as an observer, reducing coherence and generating new properties, what does that mean about our role, our own everyday interactions, just existing, observing the world around us? Are we actively shaping and manifesting reality in ways we don't even realize?
What new properties might we be inadvertently generating just by being part of this interactive universe?
It's a big question. This UOGS framework really invites all of us to look differently at the fundamental fabric of existence.
Yeah, think about how understanding coherence might change how you see, I don't know, a simple chemical reaction, the evolution of life, the way society changes. It really does offer a new perspective on how order transforms into complexity.